Okay, so I want to finish off the material on SNS, and essentially that's all I want to cover with you. So potentially I might finish my lecturing actually today, but we'll see how far we get. Uh, there is, fortunately or unfortunately though, there's a second assignment that I need to just talk my way through with you. So I'm planning to give that some few moments at the end of the lecture, irrespective of whether I finish my slides or not. So we'll just see how we get on. So in terms of the slides, I'm looking at these slides here. And so if you've actually walked your way through some of the lab, I've forgotten what the submission date for that lab was, but so you already have some experience of playing around with SNS. And I think roughly where we finished off the last day, well, it wasn't here now, but just to recap a little bit, I guess. One of the key differences between SNS and SQS is with SNS, every message that's uh, sent into an SNS topic, uh, every message is sent to every subscriber. Yeah. And that's often kind of referred to as this fan out kind of pattern. The subscribers, there are lots of different types of subscribers in the image that I'm showing you here. All of the subscribers happen to be SQSQs, which presumably then would have a Lambda consumer feeding off of those. But you could have a Lambda, as we know, you could have a Lambda that is a direct subscriber to uh, your topic, your SNS topic. And I think where I finished off the last day was, well, if I've got a Lambda here that's uh, getting its messages from the SQSQ, and I've got a Lambda here that's getting the messages directly from the topic, why would you choose this approach over this approach? What are the advantages of this over this, and vice versa? Yeah. And um, so we have a slide on that. And one of the advantages of this approach is that the message that's in your SNS topic, it's going to get to this Lambda quicker than it is to this Lambda because SQS performs batching. So SNS might send a couple of messages to the SQS queue subscriber, but it's not until the Lambda service, and kind of the way I represent the Lambda service is it's kind of a box around your actual Lambda. It's not until the Lambda service polls the SQSQ for a batch of messages and then receives them and then passes them on to the Lambda function. So there is a delay there, like in the terms of the frequency of the polling. Uh, Whereas this Lambda here would have gotten the SNS message immediately it was put into the topic. Okay. And then also there's no concurrency control over this. We do know that you can have concurrency control over this. By that I mean if there's a large volume of messages in this queue, then the Lambda service will spin off concurrent instances of the Lambda to deal with the messages, whereas you don't have that here. So hopefully this Lambda can deal with the volume of messages that are being sent into the topic. Also, one advantage of this approach is that if the Lambda cannot process a message for whatever reason, then we can set up a DL queue to take those faulty messages and deal with those somewhere else. You don't have that option built into the SNS service. Okay. Uh, and so yeah, so there are some of the kind of contrasts between the two approaches. So really the only advantage of this one is if the nature of the messages is such that they need to be processed as quickly as possible, or as soon as possible, really, sorry, as soon as possible. In other words, once they're published into the topic, we want the processing to be done by our Lambda. We want that to happen as soon as possible. Then this is the best approach to take. Okay, so it was this slide here that was kind of summarizing those. Yeah. Now, where I want to pick it up then is, well, okay, if I've got a lambda, is that what I want to do next? Sorry. Uh, okay, well, let's follow the slides maybe. Um, so SNS has something called a delivery protocol and policies, and what it relates to is its policies around the delivery of messages to subscribers, and SNS follows a certain policy depending on the nature of the subscriber. And in particular here, kind of what the policy deals with is, well, what if SNS cannot deliver the message to a subscriber because the subscriber is not available at a particular point in time? You know, maybe the actual AWS node or server that's hosting the subscriber service, for whatever reason, that's either the node has crashed or it's on a part of the network that's not available temporarily. How does SNS deal with that? So SNS cannot deliver the messages to its subscribers in that case. So how does it deal with that? And uh, how it deals with it then is defined in policies that are kind of built into the SNS service itself. Now, so what we're only talking about here now is SNS's ability to deliver a message to a subscriber, whether that subscriber is an SQSQ or a Lambda or something else like a load balancer or API gateway. It's only these delivery protocols and policies only deal with SNS's ability to actually deliver the message. Whether the subscriber can deal with the message, let's supposing the subscriber is a Lambda, a direct Lambda subscriber, and that Lambda cannot process the message, it throws an exception. Well, these delivery policies have nothing to do with that. They only concern the ability to deliver the message. And on the next slide, this is just taken directly out of the SNS documentation. And in particular, and so what this is showing us is this delivery policy that SNS follows. Yeah. And there are two types of subscribers from SNS's perspective. There are subscribers that are managed by AWS itself, and then there are actually subscribers that are external to SNS. You have to remember now that the SQS service and the SNS service, they predate all of the kind of EC2 and Lambda, all of that compute. Really, what SQS and SNS were created for initially was to allow two different organizations who would have their own servers and their own compute power to allow them to communicate with one another. So you might, you know, if you had a customer and a supplier, that kind of scenario, to allow two systems that were hosted on premise by two separate organizations. If you want to enable them to communicate with one another, then that's what the SQS and SNS service was created for initially. So that's what we're dealing with down here. Now we're not interested in this part of this table. We're only interested in this part up here. And the AWS managed subscribers that we're particularly interested in are clearly these ones down here. There are other ones as well. And so, like the table is telling us, right, that so again, this table is telling us about SNS's policy for delivering messages to a subscriber. And so what it does is it obviously tries to deliver the message, and it can't because the subscriber service is not available or is crashed. So it tries three times without any delay. And if it still can't deliver it, because the service will tell us that I have received your message. If it can't deliver it, then it tries two more times with a 1 second delay. If it still hasn't done it, tries 10 more times with a delays between the 10, and it keeps on going, right? So it actually tries 100,000, what is it, 100,000 times over a 23-day period. Okay, so it doesn't give up easily. Right. Now we can't really simulate that because, I'd have to have some way. Well, I could actually, one way I could prove that that actually happens is if I created a Lambda subscriber and then changed one of its IAM policies so that it cannot receive messages from an SNS source, right? And then that means that the SNS would not be able to deliver the message. I think that's one way I could prove it, but I'm not going to do that. But what you would, if I could set it up, then what you would see in the well, you wouldn't actually see it in the log stream. When I think about it now, you wouldn't see it in the log stream for the Lambda function itself because it never gets that far. It's the actual Lambda service that we'd somehow have to make unavailable. So anyway, it's not easy, if not even impossible for me to actually demonstrate it. So these policies are mainly around, I suppose you could regard them as guarantees that the AWS people give us about its ability to deliver messages from an SNS topic to an AWS managed subscriber. So so it's pretty reliable, I guess we could nearly conclude based on how often it keeps trying. Now, let's supposing it can actually deliver the message to a Lambda subscriber, okay? And that Lambda throws an exception. It has a problem dealing with the message. The problem is, though, that SNS doesn't care about that. I'm saying here at the very start, right, that SNS invokes a Lambda function subscriber asynchronously. Now, what I mean by that is SNS will try to deliver the message to the Lambda service. And we saw from the previous screen that it keeps trying. But once it gets a response back from the Lambda service saying, I have received your message, then SNS is out of the loop at that stage. It doesn't wait around to see did the actual Lambda function have any problems dealing with the message. However, the real life situation is that the Lambda function, may throw an exception while processing a message. And so who deals with that exception? And the way we deal with it is through a DLQ approach. But the DLQ has to be somehow managed by the Lambda service itself because we don't have an SQS service involved in this scenario now at all. We've just got SNS sending messages to a Lambda that's directly subscribing to it. So we need a way of defining a DLQ, dead letter Q, and link that dead letter Q directly with a Lambda function, and then the Lambda service will actually take care of putting the faulty message into that DLQ, and the DLQ is an ordinary SQS queue, okay? Um, and so the Lambda service will actually manage the shifting of the message onto the DLQ, and then we can have another Lambda function that's processing those faulty messages. So here's a simple architecture that we'll just look at. Where our publisher, we've got an SNS topic. Our publisher, just for convenience, is the CLI. We've got a Lambda that's a direct subscriber to this topic. And we can configure this Lambda so that it has a DLQ associated with it. And we've got a Lambda then that's processing whatever goes into that DLQ. Okay. So the question is, when we publish a faulty message or, whatever, some sort of message that has some errors associated with it into our topic, SNS will deliver the message to the Lambda subscriber. So it doesn't care about anything else. It's out of the loop. So what actually happens is that the Lambda will try and process the message. It'll throw an exception because it finds some error. And the Lambda service will actually retry. I'm drawing a box here, I guess. So the box is my Lambda service now, which is managing the Lambda. The Lambda service, when the Lambda function throws the exception, the Lambda service will retry the Lambda function 3 times. It'll give it 3 goes at trying to process the message. Because sometimes a Lambda might not be able to process a message because the actual Lambda function itself times out. Maybe this Lambda needs to communicate with other resources, like a database or something else. And for whatever reason, the response that it's getting back is too slow, in which case this Lambda function actually times out. So maybe that's the reason why it failed to process the message. And maybe after the second or third retry, the other service that it wants to communicate will respond actually quicker. And so that will allow it to process the message fully. Either way, whatever is the reason, the Lambda service will try it 3 times, and after the third attempt, then the Lambda service will put the message into the DLQ. And then this will, the Lambda service again will poll the DLQ in order to allow this separate Lambda function to process the invalid message. So it's this three retries that the Lambda service performs for us. And it's how we connect up a DLQ directly to a Lambda. They're the 2 things that we need to look at. So if I go over to VS Code, so I've got a simple little project here. The messages that I want to publish to the SNS topic are these messages. Okay, and let's supposing the Lambda subscriber, one of the things it looks for in my message is that there's an address property. And if there isn't, then it's going to throw an exception. So if I take out that from my message, so it's now an invalid faulty message. If I look at my stack, there's nothing particularly new in the stack now because we've seen a lot of this stuff already. But just quickly to run down through it. Okay, I've got a topic, SNS topic. This is the DLQ essentially. This is the Lambda that's a subscriber to the topic. And here's a new property that we haven't seen before on failure. So this essentially is connecting this Lambda with some sort of a destination where faulty messages should be sent to, because there are other options other than a DLQ. But in my case, you can see that I'm actually connecting my queue as the destination for faulty messages. Okay, and really the rest then is we've seen before. So this is the only new configuration that we haven't seen before for a Lambda. And all I'm doing here then is, so this is the Lambda that's processing the messages in the DLQ, and then I connect up things together. And I'm outputting the ARN of my topic so that I can send messages to it. And so if I just clean up my logs first. Okay, no log groups. And I want to send the message. So the message I'm sending is the one I've showed you, and I've taken out the address property. Maybe I should just quickly look at the subscriber just to confirm. You can see this is the Lambda subscriber to the SNS topic, and you can see here, look, it's checking to see does the message have an address property. If it doesn't, throw an exception. And I am hard coding it to, okay, well, let's just ignore that for now. Right, let's send the message. Here's my log stream for the subscriber. Okay, there's one hanging around from earlier, I think. Looks like it's this one. Yeah, so it created a micro VM for my Lambda. It ran the initialization code. Then it called the Lambda handler function itself. This is the console log of the full message. And it looks like there's the error. Okay, so it threw an exception. Now, so the Lambda service now picks up the fact that this Lambda function threw an exception, and it knows it has to deal with it because I've configured that on failure property in the Lambda. And so the Lambda service will delay for a short period, and then it'll try and invoke it again. So we just need to hang around a little bit until it has a second go, and then it has a third go. I won't wait for the third one because it can take a couple of minutes, but if I just go back, or if I just do a refresh on this a couple of times, maybe. No, it hasn't invoked it yet. So we just need to sit tight for a while. Now, eventually we will see the log stream for the second Lambda appearing here. That would be the log stream that's dealing with the DLQ. But of course, that won't appear, that log group, sorry, won't appear until the Lambda service has tried the Lambda subscriber 3 times with delays between each attempt. Now, hopefully it has had a second invocation of it at this stage. Yeah, so this was the first invocation. This is the second invocation of the same, and it's using the same micro VM. It's using the same micro VM because there's no concurrency control. This is one of the things I mentioned about Lambda subscribers that are, sorry, Lambdas that are direct subscribers to the SNS topic. But the second invocation is the same outcome, throws the exception again, presumably. Yeah. And if we waited around long enough, it would try a third time. And then after the third time, it then will send the message into the DLQ. And when we look at the log groups, then we would see the second log group appearing to prove to us that the Lambda that's dealing with that. In fact, it has happened, has it? Yeah, this is the log group uh, for the DLQ consumer, which means if I actually go back to this one, you won't see all three of them now, but just do one refresh and I won't hang around any longer for it. No, it's not showing me all three, but maybe I'll come back to it a little bit later on and we'll see that there are three, even though it has triggered the other Lambda, which means it has actually tried 3 times, but just given the way that CloudWatch logs work, they can be a bit slow to actually appear. Okay, so the point there is if you've got a Lambda that's a direct subscriber and the Lambda has some problems with the processing of the message, SNS, you cannot configure SNS to deal with that. You've got to configure the actual Lambda function itself, which will get the Lambda service to deal with any error handling. That doesn't arise now, of course, if this Lambda was behind an SQSQ. So in that case, my SNS is subscribing to an S. Let me just clean that out. Sorry. So if I've got a queue here, actually, that's my queue. SNS is sending message to the queue. My Lambda is now here and it's polling the queue. Of course, if this Lambda throws the exception, then I can configure SQS to have a DLQ and that DLQ can be processed by another Lambda. But this configuration I do within my queue configuration. This is the DLQ, but this DLQ is configured in my main queue, if you like, whereas this DLQ is configured as part of my Lambda function configuration. In general, when you've got event-driven applications or asynchronous communication between the components in your application, one of the things you always have to deal with is error handling. It's fine programming your application for dealing with the normal scenarios, when there aren't any errors uh, in your communications, but dealing with the error scenarios is what you have to be particularly careful about when you're dealing with event-driven stroke asynchronous based applications. Right, let's move on. Another aspect of this SNS service is filtering. So what I'm illustrating here is supposing, and by the way, you can have many publishers, but supposing we've got a publisher that's publishing different types of messages. Okay, that's what the color coding meant to reflect here. Then, and the your subscribers only want to receive certain subsets of messages based on some sort of properties of these messages. Now, fortunately, you can actually configure the subscriptions um, to perform the filtering for you. You know, you don't have to do it at the subscriber level. You actually do it at the subscription level. I always kind of imagine the subscription is something that's sitting between SNS and the actual subscriber. So there's a kind of some sort of a subscription resource sitting in here. And it's that subscription resource that you configure a filtering policy for. And each subscriber has its own subscription resource. And the filtering then will perform, the necessary job of only allowing certain messages to be passed on to the subscriber. So how do we configure this filtering? So it's filtering policies. We can define filtering policies for each subscriber. And a policy has to have a filtering criteria defined for it. Now, first of all, I'm saying that the filtering policy can either be based on attributes of a message or the actual body of the message itself. Yeah. So the message body is always a JSON structure. So you can define filtering based on properties of the body, but you can also have what are called attributes, which is kind of like metadata maybe, but it's attributes, which is a separate JSON structure, and the attributes is a separate JSON structure, and you can actually define a filtering policy which is just focused on the attributes of a message, not on the body. And you can actually combine them. You can have a mixture of them. The attributes is also a JSON structure, and the body is a JSON structure. Now, the criteria then can be either a string filter, a number filter, or an exist filter. A string filter would apply if we just deal with, let's say, the attributes. Let's say one of the attributes in the attributes JSON structure, its value is a string. Then you can say that you only want certain values to be in that string attribute. So you can specify what's called an allow list. And the allow list will list the values that you are permitting in a particular attribute. And if that particular attribute has one of the values in that allow list, then you want that message to be passed on to the subscriber. Alternatively, you can specify a deny list. And so in the deny list, you'll have this list of strings, which if the particular attribute has one of those values in the deny list, then you're saying do not allow that message to go to the subscriber. Third option is a prefix, a match prefix. So where you're saying if the string value of a particular attribute, if it begins with a certain prefix, then you are allowing that to go through. These same three filtering criteria can apply to a body attribute, to a body property as well. Yeah. A numeric filter is whether it be an attribute property or a body property, but its value is a numeric value, then you can have, again, an allow list, a greater than, less than, between, upper and lower limit. Okay, so you can specify criteria along those uh, uh, strategies. The exist filter is just saying if a particular, let's say it's an exist filter on an attribute property, then you're just saying if the JSON attribute structure contains a particular property, I don't care what its value is, but if it has a particular property, then you want that message to be passed on to the subscriber. Similarly, if it's related to a body property, all you're just checking for is the presence of the property in the body structure itself. And if it has it, then allow the message to go through. That shouldn't be there. That's just stuff I should have taken out. Okay, let's see an example. And now that I think about it, if you have completed the lab, then you've already seen this example. So my architecture is, okay, so my publisher to my SNS topic is CLI again. I've got 2 subscribers, and they both have filters associated with the subscribers. As I said, this is really what you have played with in the lab if you've done the final section of the lab. Uh, I'm specifying here the policy associated with this subscriber. Okay, and so the Lambda subscriber only concerns messages or is only interested in receiving messages with the user type attribute set to either student or lecturer. Okay, so it looks like user type, number one, it's an attribute of the message. It's not a property of the body of the message. And it looks like its values are strings. And so we're saying it's only if it has the string student or the string lecturer. So we would use the allow list filtering criteria to specify that policy. So here's excerpts from the code. Here is my subscription. So I've created a topic somewhere in my stack. I'm adding a subscription or a subscriber to it. Sorry. I'm adding a subscription to it. And it's a Lambda subscription or subscriber. And here's how I specify the policy, the filtering policy. This here has to correspond to the actual attribute name or the actual attribute property name. And then the rest of the syntax is where I specify the criteria. So I'm using the allow list approach, and it's always going to be an array, even if it's only one value. The allow list is going to be an array, and so as the said on the previous screen, previous slide, these are the 2 only values of this particular attribute that we are interested in passing on to the Lambda subscriber. So this might be my message. This is the actual body of the message. This is the JSON structure that contains the attributes that I want to associate with that message. And you can have many attributes. The way you specify the attributes is slightly long-winded, but that's what's stipulated by SNS. So it's the name of the attribute, essentially kind of what type it is. It's a string attribute. And sorry, it's a string attribute and then the value of that attribute. I have another attribute, but it turns out that this attribute is not of any concern to this filter over here. If I did want it to be part of the filter, then I would simply, have another, you can see there's a comma there. I would have another, I would say source here. It's source, yeah. Source as being another attribute and specify the filter using the same set of syntax as I'm using here. And so I'm not going to demonstrate this one. You do it in the lab anyway. but I'm showing you the key parts of it. And really, this is the only part that's new. Yeah. What I'm showing here is a screenshot from the actual Lambda subscriber itself, and uh, I'm showing you a console log of the event parameter that's passed to it. And so as we've seen before, this is what an SNS message looks like, but the two key parts of it is, well, the SNS message has a body, and as well, it has this attributes part, which we haven't seen before. So if there were no attributes, then this would be just an empty array. Uh, is it an array or is it an object? It's an object, sorry. But now we can see that we have a use for it. And so because I'm showing you this screenshot and the user type is lecturer, then it looks like, well, it looks like the message did get through and should have gotten through because my filtering policy said it should. But if I had set it to something other than student or lecturer, then you shouldn't see that message getting through to the Lambda subscriber. Okay, that's filtering based on the attributes associated with a message. What am I doing here? Sorry, now I've just started off something that I didn't want to do. Give me 1 minute. Right. Message body filtering, all of it is kind of similar, but in this case, we're doing the filtering based on properties of the body as opposed to properties of the attributes. The body is always going to be a JSON structure. Same filtering criteria as I already said to you. Let's look at an example. And the example is actually based on the lab as well, even though we didn't do any filtering on the messages that were being published by the S3 service, but you can. So I've got S3, which is publishing messages to an SNS topic. Okay, I've got the CLI over here, which is uploading or carrying out some sort of operation on an S3 bucket. My S3 bucket is publishing messages to the topic, and then I want to do a filter based on the body of the S3 messages. Okay, so that's kind of slightly complicating it. It's not a message that I have published directly onto the SNS topic. It's actually a message that another service has published. So we need to understand the structure of messages that are sent by this other service, S3. We need to understand the structure of those messages, the body of the messages, in order to specify a body filter here. And the filter is just happens to be going to an SQS subscriber, and it has a filter, or sorry, a Lambda function consuming off of that. The filter only allows messages. All right, so this is what I've decided, that I only want to allow messages to get through to the SQS queue if the image or the file that was uploaded to S3 began with the substring image. Okay, so only files whose name starts with image, doesn't matter what if there's another part to the name, or it doesn't matter what the type of the file is. If its name begins with image, then I want that message to appear in the SQS queue so that my Lambda can actually process it. So in the lab, what you did was you have all of this architecture, you just don't have the filter part in what you did in the labs. So we need to look at how we do that. And the filter in this case is a message body-based filter. Now, I said there that you need to understand, though, the structure of the messages that are being sent, that are being published into SNS before you can actually define your body-based filter. And so the screenshot that I'm showing you here is taken from this Lambda over here. Maybe I probably did it before I did any filtering. Okay, so that I can see the actual structure of the messages. And we've kind of seen this before, right? So here's the body of the message. And again, now this is a message that was published by the S3 service to an SNS topic before it ever got onto the SQSQ and onto my Lambda consumer. The message body is serialized, so I need to parse it. And when I parsed it, this is what I see. Okay. So again, at the risk of annoying you, this is the message, the structure of the message that was published by the S3 service onto my SNS topic. And so this is the message body that I want to define a filter on. And you can see that, there's a record property at the top level of this message. And within it, it has a sub-property, if you like, called S3. S3 has an object, is a value, and that object has a property called object. And eventually we get down to the actual file name. The file name is here, right? And our filter wants to be based around this string here, if you like. So what we've got to describe in the body filter is we've kind of got to tell it where exactly is the property located within this overall structure. Where's the property that we're actually doing the filtering on, well, that we've defined the filter criteria on. Okay. Again, I'll say that we've got to describe in our filter policy, we've got to describe where exactly within this complex JSON structure, where exactly is the property that it should focus on for applying the filter criteria. And this is how we do it. So this is just taken out of the stack file. So I've defined the topic somewhere else in my, I've defined the topic somewhere else in my stack. I'm adding a subscriber to it. It happens to be an SQS subscriber. That's not particularly relevant, but it could be a Lambda subscriber, but it's an SQS subscriber. And here's where I'm defining the body message body-based filter. Note the key here is filter policy with message body, as opposed to, if I might be allowed just to go back, as opposed to filter policy. Filter policy is where you're defining a message attribute filter policy or filter criteria, whereas now we're defining a policy around the message body. So it's just a different key, if you like. And I'm just checking, can people hear me?
Yep.
Yep.
Yeah, it broke down on my side. Did it break down on your side?
It did.
Yeah,
Yeah.
you just disconnected.
Yeah. Okay, we're back up again. Right, let's see. Can you see my screen?
Not yet.
Okay, I need to reshare in that case. Okay, so when it reconnects, it actually resets everything. So I'm guessing now that you can see my screen.
Yeah, we can see it now.
Okay. So right, how we define the message body filter is like this, and in a sense, it's a lot of it is boilerplate. Like all of this stuff over here is kind of boilerplate, but the key things are I'm actually describing the structure here. The top of my structure, as you remember, was the records key. Then within that record structure, there was a key called S3. Within the S3 structure, there was a key called object. What I'm talking about now is this structure here, yeah. Um, and within the object structure, there was a key called key. Okay, so we're now down to here. Yeah, we're down to here. And now we can actually define the filter criteria. And the filter criteria is a match prefix, which is one of the three options. The three options were allow list, deny list, deny list, and match prefix. And match prefix is the one that's suitable in this case. And you can actually, it looks like you can define a number of prefixes. We only are interested in one though. So the net effect of all of this is when SNS receives a message and the structure of that message adheres to this structure here. And once it digs down into the property called key, it looks at the value of that property. And if the value begins with that, then it will allow the message forward onto the subscriber, which happens to be an SQS subscriber in this case. So as I said, it's actually a bit clumsy the way we have to describe the structure, but we have to live with that. Of course, if the publisher to the topic in the first place wasn't S3 at all, it was some other service, then we would have to look at the structure of the message that was published by that service. So you always have to have a clear understanding of the message structure that's actually being published onto the topic before you can define any kind of message body based filter. Let's see it in action. So if we look at the stack, and essentially this is very like the lab that you've submitted for me. So again, we've got our bucket. We've got an SNS topic. We've got a queue. What's that for? Oh yeah, so it's the queue actually is going to be the subscriber to my topic. I've got the Lambda, that's the consumer for my queue. Nothing interesting there. Then I hook things up. So I'm adding a subscriber. This is what we've seen on the slides. And I'm also just connecting my Lambda to my queue, I think. Is that what I'm doing here? Oh no, sorry, yeah, let's not skip over this now. Although you've seen it in the lab. This is where I'm describing, what am I describing? I'm describing the messages that are being published onto the topic by my S3 bucket. And so it looks like, I can specify what types of events happen to the bucket which should cause the bucket to publish a message onto the SNS topic. That's what we're doing here. because there's lots of things that there are lots of um, events that could happen to my bucket. Like a new object is added to the bucket, an object is updated, an object is deleted, CRUD essentially, right? They're all different types of events, and maybe it's only some of those events that we want to ask the SNS, sorry, that we want to ask the S3 service to publish messages about them onto the SNS topic. And so in this case, it looks like I'm only interested in uh, events that relate to new objects being created in my bucket. That's fine. And here I am just connecting the Lambda to the queue. So that's just ordinary stuff we've seen before. Sorry, is that what I'm doing there? What am I doing here again? Oh no, I'm creating the event source between the queue and the Lambda, and then I'm just hooking them up. I'm giving the Lambda some permissions to access the bucket if it needs to, and then I'm outputting the buckets the bucket name. Right. So that's my architecture. And do I need to look at the lambdas? I don't think I do. No, the lambda is what we've seen in the lab, so I don't think I need to go through that. Let's just trigger this whole event source. So that's
Dermot,
mm-hmm.
I think before you do that, I should let you know that you may have added a few spaces and text into the EDA appstack.ts file, just
Okay.
so you can save time for error handling.
Let's undo that if I did. Is that where I did it?
Yeah, but then there was also you added, what are they called, those inverted commas at the bottom as well. There's quite a few of them that was added, and I think you might have accidentally pushed a button. If you scroll down a little bit more, you should see it.
Oh, that is it?
Yeah.
Yeah, okay, good. Let's just undo that. No, I've actually already deployed it. So as you can see down here, so if I just take the bucket name, so if I call, let's see, if I call this picture of an image, then it should not trigger my Lambda because the message will never get to it won't pass the filter. Maybe before I do that, if I just clean up my logs. And if I follow it with another upload, but I'll call this one image one. And that should get through my filter. So the bucket has two files in it now. But if I look at the log groups, and we've only got one Lambda. I wonder, did I, when I undid those changes now, did I? Okay. So this is the log group. And if we go into the stream, first thing we notice is that there is only one invocation of the Lambda, but that doesn't necessarily confirm anything. If we look at the, let's see. Okay, so this is the actual, what am I looking at here now? Oh yeah, this is the S3 message, is it? Uh, yeah, this is the, or it's an S3 message, but if we keep going down to here, okay, so we've gotten the image one. Now, picture one was sent before image one, but I don't have any log stream for picture one. So that's proving to me anyway that the filter never let that message through to the SQS queue, which eventually was polled by my Lambda. Yeah. So that's essentially body-based filtering. You can have your body-based filter can specify, more than one property of the message body by simply, repeating this kind of stuff as a separate, because this is an object, okay? Somehow repeat. I haven't done it now. Actually, I might play around with that actually, but you can anyway. In general, you can have your body-based filter based on more than one property. Right. Okay, this is just another example of a body-based filter for my S3 messages, but in this case, my criteria is that I only want messages with the S3 schema versions of 2.0. Now, the S3 schema, if I go back and look at the structure of the message, the S3 schema is here, right? So if that's the property that you wanted to do the filtering on, then the body filter, looks like this. Again, you're describing the structure as we did before. And you can have a combination of body-based filtering and attribute-based filtering, kind of to your heart's content. You can mix them up in one subscription declaration. So the only closing point I'll make is that certainly the syntax is long-winded and clumsy and certainly very error-prone. But we just have to live with that. And this is specific to when the publisher is an S3 uh, service. It would be a very different structure if it's some other service that's publishing. And so you've got to always study this, the structure of the message itself. Okay, we're coming close to the end of this set of slides. And so all I'm doing here is kind of reminding ourselves what's this all about? Why are we looking at these messaging services? And the whole purpose of it was to decouple the compute components that make up your application rather than having one, let's say it's a Lambda, rather than having one Lambda invoke another Lambda and that Lambda invokes a third Lambda. So there's strong coupling between those Lambdas. And of course, if it breaks, if any one of those Lambdas break down in terms of they might time out or throw an exception, then there's a knock-on effect back through the chain. And so if you can decouple them, then you should. And the mechanisms that we can use are SQS and SNS, which we've looked at. There's also something called data streams, which I just want to look at next briefly. Now, this slide here actually is a slide that I showed you way back when we started talking about Lambda on day one. And one of the aspects of Lambda that we were talking about was Lambda integration. That is, when you've got something else, some other service that wants to trigger a Lambda, what are the different integration strategies that are used by AWS? And there were three, or integration types, I suppose, and not so much strategies. There are three types of integrations. To note now, this is not Lambda talking to other services. This is other services talking to Lambda or triggering Lambda. And there were three types of integrations: synchronous, asynchronous, and event source or polling based. And this slide is talking about the event source mapping or polling based integration. And we're very familiar with that now when we talked about SQS, right? Because we know that if SQS wants to send some messages onto a Lambda function, then the Lambda service polls the SQS service for those messages. So we're very familiar with that. Now, it's a similar type of integration that happens with what are called DynamoDB streams. Now, what are DynamoDB streams, though? And so the image just showing you here is explaining both DynamoDB streams and the nature of this integration between a DynamoDB stream and a Lambda function. What a DynamoDB stream is, so you've got some sort of a client that's making changes to a DynamoDB table. This can be a Lambda, can be anything, right? But it's making changes to the table, as in adding new records, modifying records, deleting records. We can configure the table to keep a log of all of the changes that happens to a table. And that log is essentially a DynamoDB stream. Now, what we want to do is we want to have a Lambda function which is triggered by entries in that stream. And the stream it's a bit like, an SQS queue with messages in it. Each entry in the log stream is essentially kind of a message where the message describes what has happened, what change has occurred in my DynamoDB table. So I can configure this Lambda to be triggered by entries occurring in the DynamoDB stream. And the way it works is really the exact same way it worked when we had an SQS queue here. So what happens is the Lambda service polls the DynamoDB service, asking it, have there been any changes in this log stream? It will receive a batch of those changes, and it'll store that batch internally in a queue This is not an SQS queue now. This is just some other sort of a queuing data structure that's internal to Dynamo to Lambda, the Lambda service. And those batches then are fed to my Lambda function in the exact same way that it would work when it was an SQS queue that was up here. Okay, so it's a DynamoDB stream now. That's the source of the events for this Lambda function. And to go back to, if I go back to this slide here and I talked about decoupling your compute components, well, typically the client here is actually going to be a Lambda. And so the processing that's being done here, rather than that processing being part of this Lambda, we have broken it out into a separate Lambda. And whatever the nature of the processing is, that processing can happen sort of later on. It doesn't have to happen within this Lambda. We've made that decision. Okay, so we've decoupled these two. Now, so it's only the mechanics really of how do we connect up all of this, right? That's all I'm interested in showing you. So how do we declare a stream for a particular table, and how do we connect up that stream as an event source for my Lambda function? Well, here's how you tell the DynamoDB service that it should maintain a stream for a particular table. So it's this property here. Yeah. And the value you give to this property, which I'll talk about in the next slide, I think, the value describes exactly what do you want DynamoDB to put into this stream? What do you want to store in the stream? That's what we mean by the type here, the stream type. Here I'm showing you how you connect up your Lambda to that stream. In other words, how do we connect this Lambda to the stream? And so it's just an event source, right? But it's a DynamoDB stream event source. So this is a new type of event source that we haven't seen before. We've seen an SQS event source. Now it's a DynamoDB event source, and it's kind of polling based, right? I wouldn't worry about this property. It's boilerplate, let's just say. So that's how you define the stream. That's how you connect them up. And then, DynamoDB service and the Lambda service will essentially take care of the rest. Again, note that this function, this Lambda function, it will receive batches of entries in the stream. So you have to process them as batches. What you do with each entry, that depends on what the nature of the processing is. Now to go back to this point here about the type. What am I doing here? Oh, sorry. Sorry, no. Oh yeah, the type that you want to have associated with the stream. That's what I'm documenting here. And the type essentially controls, I'm saying, what is actually written into each stream entry. And looks like that there are three options. The first one is where you want the complete new table item itself written into the stream. So if you imagine the change that has happened to my table is an item has been updated. What you want written into the stream is the updated copy of the table item. That's what new image means. Also, if the change that has happened to the table is a new item has been added to the table, then you essentially want that new item to be added to the stream as well. New and old, that applies if it's an update operation that has happened to the table and you want the new uh, the new values of the item and the previous values of the item, the table item. In other words, you want the pre and post copy of the table item written into the stream. So that means our Lambda function will be able to see the new value, the new state of the table item and the previous state. This one is where you only want the previous state of the table item to be written to the stream. And in this one, we only want the keys of the particular table item, that being the partition key and sort key, if there is a sort key. That's all we want to have written into the log stream. Right, so that's that really. And it's only a case then of just playing around in terms of understanding what this Lambda receives in each batch entry, just use console log. I think I actually just say that here, right? Just use console log within the Lambda so that you can develop an understanding of the structure of the events that are written to the DynamoDB stream. Console log it so that you can understand how your processing should sort of dig out information from the stream itself, from the stream entries itself. I'm not giving you any examples of that, so that's something you would have to explore in your own time. Right, where are we on time? Good. What I'm going to do now is go back to the website and talk about the second assignment. And the second assignment is built on top of what you submitted for the last lab, what I'm calling the event-driven architecture lab. So in that lab, we just maybe bring that up. In that lab, you've created this architecture. Yeah. So that's your starting point for the assignment. Back to the assignment. And if I just skip on to the detail, so the way I've defined or described this assignment is I've defined it broken up into 3 phases. So if you're aiming for between 40 and 50%, then you need only do phase 1. If you're aiming for something between 50 and 75%, you're aiming for phase 2, where phase 2 obviously builds on top of phase 1. And if you're aiming for a mark higher than that, phase 3, then you're looking at doing some more stuff, building on top of phase 2, essentially. So let's go back to phase 1. Phase 1, what's different between this architecture and what you produced in the lab is we want to associate, so in the lab, as you know, a user can upload an image to the bucket. The bucket sends a message to my SNS topic. The SNS topic has an SQS queue subscriber. That subscriber has a Lambda consumer. And at the moment, your Lambda consumer doesn't really do anything. Okay, it finds out the name of the file that was uploaded to the bucket. And it does that by drilling down into the message that it received from SQS, right? But what I want you to do in the assignment is I want you to write to a table the name of the file that was uploaded. So this DynamoDB table, it has a very simple schema. It just has a partition key, and the partition key is the name of the image. That's not a very good partition key for a table, but we'll just ignore that. Okay. And there are no other attributes initially for a table item. It just has one attribute. That's the partition key, and the partition key is a string, and the string value would be the name of the file that was uploaded to the bucket. Okay, that's what this Lambda does. However, this Lambda checks the file extension to make sure it's a JPEG or a PNG. And I think you already have the code that does that. And if it finds the file extension is not one of those two, it's going to throw an exception. And I want those messages to be put into a DLQ. So you need to configure a DLQ for this one. That queue has a Lambda function, and the Lambda function is going to send a message, an email to the user telling it that the file that it uploaded was the incorrect format. So you know how to get a Lambda to send, did I say SNS? SES messages, emails, okay? So you have the code to do that, but this is just a new Lambda. This Lambda up here, you already have, but in the lab, this Lambda was linked to an SQSQ, and that SQSQ was a subscriber to the SNS topic. So I just wanted to take that SQSQ out of the picture, out of the architecture, and just make this Lambda a direct subscriber to the topic. That should be pretty straightforward. So really, it's only this stuff down here, the table, the DLQ, they're the only new features that you have to add to the architecture in order to satisfy phase one. Moving on to phase two. Let's stop for a second just in case there are any questions. Phase two, we're allowing the user to write messages directly to the topic. And the purpose of these messages is to provide some what I'm calling metadata associated with a particular image. So the metadata might be maybe a caption that you want to associate with the image, or the date that the image was taken, just in simple format, a string format, 21st of the 11th, 24, but it's just a string really. Or the metadata might be the name of the photographer. It doesn't really matter. It's a string in all cases, but it's metadata for associated with the image. Now, those messages, we only want those messages to be processed by this new Lambda down here. Clearly, well, not clearly maybe, but those messages should not be written to the queue because they're not relevant to this Lambda over here. And similarly, those messages should not be sent down to this Lambda because it's not concerned about them either. So we need to do some filtering. The only Lambda that's interested in those types of messages is this Lambda down here. And what it will do is, because the message will actually contain the name of the file that this metadata is associated with. And so what this will do is it will update the table with the piece of metadata. So it has the partition key for the table item because the message will contain the actual name of the file, and just update the table. And surprisingly, that's it really. So it's these filters and this whole part of the architecture you need to build in to complete phase two. Now that I think about it, it's probably not a lot, but anyway, that's okay. Phase three, well, before I move on from phase two, so I'm showing you here, this is the an example of what the body of this metadata message might be. Okay, so it'll have the ID property, which will be the name of the file, and the value property, which will be, this could be the caption. It looks like it's a caption in this stage, in this example, but it could be a date, it could be a photographer's name. It doesn't really matter what's contained in the string. Whatever is in the string, that string needs to be just added to the appropriate table item here. Uh, 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 okay, the attribute is actually, I've kind of forgotten myself now. The attribute is telling us what the nature of this value is. Okay, all right. So the attribute is telling us the nature of this value. And so it looks like that the value in this case is a caption for the image. I think you would use that then. That then would become the name of the attribute in the table. Yeah. Because if you're adding a new attribute to this table, you've got to give that attribute a name. And so the name will be contained in the attribute associated with the message. Okay. And I'm showing you how to send a message via the CLI, which you probably already know how to do anyway, but I'm just showing you how to do it there. Phase 3. In phase 3, we're now allowing a user to request the deletion of an image from the bucket. That message should be published as an event to my SNS topic. That particular message should be sent on to the SQSQ. It should not be sent down to this Lambda. It should be sent to the SQSQ, which means this Lambda receives it. So now this Lambda is going to be dealing with two types of SNS messages, those that related to the user uploading an image and those that relate to the user deleting the image. For the second case, clearly what it needs to do is it needs to delete the corresponding item in the table. Okay, that's that. The other change that I've made is if I go back to, let's say, phase 2. So we have our Lambda up here, right? This is the one that's just sending an email to the user confirming the receipt of the image upload. Okay, and you already have that Lambda from the lab. But rather than that Lambda being triggered by a message arriving in the SNS topic, what I'm now doing in phase 3 is I want that Lambda to be triggered when the item is added to the table. And we know that we add an item to the table when a new image is uploaded to the bucket. So when an item is added to this table, that should trigger this Lambda. And this is the Lambda that sends the confirmation email to the user saying, we've received your image upload. So there's two new things that are in this architecture: the deleting of an image and the knock-on effect from that, and the fact that this Lambda now is being triggered from the DynamoDB stream as opposed to being triggered from the SQS queue itself. So in overall terms, when you're dealing with any kind of event-driven architecture, it's all about hooking things or connecting things up together. That's where a lot of the effort goes into. It's not so much the Lambdas, they don't do a whole lot of sophisticated processing, not in this case anyway, right? But it's connecting up all of these things and it's defining your filters so that only the relevant messages get through to the relevant subscribers. So I've only got 2 subscribers at this stage. Clearly, this one here shouldn't receive any messages related to image uploads or image deletes. It should only receive the metadata related messages and so on for the others. So it takes some time to read through the specification. I do give you some little bit of information down here at the bottom. This information relates to number one, this lambda here, because previously this lambda was an SQSQ handler, if you like, whereas now it's a DynamoDB stream handler. It's just a different type of handler. So I tell you down at the bottom what the type of handler it is, and also making this connection here. You declare that connection in the stack file, and there are certain imports that you have to have at the top of that stack file in order to be able to define them. And so I'm telling you here, look, these imports. These imports need to be in the stack file. This import, sorry, needs to be in the stack file. Is that what I'm doing? Sorry, beg your pardon. These imports here need to be in the stack file. Here, I'm just telling you the type of handler that my Lambda is. So read through the specification, make sure you fully understand it. By all means, ask me any questions in the labs. So there are no more labs actually. Did I mention that the last day? There are no more new labs. In fact, there are no more lectures either. But I certainly will start up a Zoom session for next week's lecture and the week after. I'll just hang around for 10 or 15 minutes in case there are any questions that you have for me. But there's no new material that I want to cover with you. First of all, are there any immediate questions related to the assignment that you want to put to me? I'm making the hand update essentially the last day of lectures, and this is also worth 20%. Now, of course, there is one other assessment that is going to take place on week 13, and because of all of that has been happening in the university over the last couple of weeks, I'm still not clear how I will structure that. So we've got to leave that aside for now. I can't answer any questions about it, unfortunately. But I need to decide over the coming week or two. So it doesn't sound like you've got anything that you want to ask me. In that case, I'll stop the lecture at this stage and I'll touch base with you again next week. Okay, bye-bye.